This is the Smart Buildings Academy podcast with Matt Scott, episode 492. Welcome to the Smart Buildings Academy podcast. Today's episode will be about breaking down ASHRAE 62.1, similarly to how we broke down 90.1 last week. Now, all the information covered in this episode can be found on our website at podcast.smartbuildingsacademy.com/492. Again, that's podcast.smartbuildingsacademy.com/492. So ASHRAE 62.1. This is the standard that governs ventilation and indoor air quality, or IAQ. This is for commercial buildings. Now, I'll be honest, it's one of the most misunderstood but most critical pieces in our industry. What does it take to get good air into a building? Not just cold air, not just dry air, but clean, healthy air. Air that makes people feel alert, energized, and safe. That's what we're going to be unpacking today. Now, this episode is especially for you if you're a controls tech, facilities manager, commissioning agent, or mechanical designer. But if you just like breathing, well, I think you'll still enjoy this one. So here are our objectives for this podcast. We have defining ventilation. We have explaining the purpose of ASHRAE 62.1. We have explaining the scope of ASHRAE 62.1. We're going to be providing some examples of system requirements. We're also going to be providing some examples of the design procedures. And also, we're going to be describing the importance of proper startup, commissioning, and maintenance. So what is ventilation? Let's start with the basics. So at its core, ventilation is about moving air. So it means bringing in fresh air from outside and removing stale, contaminated air from inside. But it's more than just airflow. It's about controlling contaminants, regulating humidity, and yes, keeping temperatures comfortable too. Now think about a classroom. Without proper ventilation, CO2 builds up. Students get sleepy, distracted, the concentration drops. That's not just an inconvenience, it's measurable, and studies back that up. Now think of a gym, maybe a hospital waiting room, or a manufacturing facility. Each space has very different air quality needs. And that's where the standard like ASHRAE 62.1 comes in. They help us tailor that ventilation strategy to the purpose of each space. I like to compare this to nutrition. Just like our body needs different food for different activities, protein for recovery or muscle building, carbs for energy, buildings need different air strategies depending on what's happening inside of them. Now, before we get into how much outdoor air to bring into a building, and also what ASHRAE specifically covers, ASHRAE 62.1 also says we need to assess the quality of that air first. And that makes a lot of sense, right? Because bringing in dirty outdoor air without the proper treatment is like filtering water through a screen door. It doesn't help. And it actually could hurt. So how do we assess outdoor air quality? Now, the standard tells us to look at the local environmental data. Now, that's usually from nearby monitoring stations or EPA sources. Now, we're checking for common pollutants like PM10 or PM2.5 Now the PM here stands for particulate matter. We're also looking at our ozone, our carbon monoxide, and even things like sulfur dioxide, depending on which region you're designing in or looking at. Now, if the data shows that any of these pollutants exceed the national thresholds, then we have to treat or filter that air before it enters the building. Now, the key takeaway here is that not all outdoor air is automatically fresh air. So depending on where your building is located, the air outside might need some serious cleanup before it's safe to breathe inside. We'll talk a little bit more about that later. And ASHRAE 62.1 doesn't just recommend that assessment, it requires it, especially when you're using the ventilation rate procedure, which is a method we'll talk about more later. Now, always verify the air before you design it, because if your intake strategy starts with contaminated air, no amount of airflow is going to save your indoor air quality. Here's a copy of this. Now, this can be found at www.ashrae.org/technical resources, and you can go in there and find their standards and guidelines. And again, this is for the ventilation and acceptable indoor air quality for ASHRAE 62.1. So what does ASHRAE 62.1 actually do? So it sets the minimum ventilation rates needed to ensure that people inside buildings are breathing air that won't harm their health or their productivity. So section 1.1 of the standard says it best. It's intended to provide indoor air quality that is acceptable to human occupants and that minimizes adverse health effects. So this applies to new buildings, additions to existing buildings, and even some retrofits when indoor air quality is affected. But there's a catch. It doesn't apply to residential units, just like kind of what we talked about last week with our 90.1. Those fall into ASHRAE 62.2. So your single family homes, your apartments, all fall under a different standard. So 62.1 focuses on commercial buildings like our office buildings, airports, schools, worship facilities, retail spaces, and any other commercial facilities. So it covers more than just design. It also outlines how systems should be installed, commissioned, and maintained. And honestly, this is where a lot of projects go sideways. I've been on a lot of jobs where the design met 62.1 perfectly. However, the dampers were installed backwards, or the filters weren't replaced for an entire year. Good indoor air quality isn't just a design concern. It's a life cycle concern as well. Now let's talk systems and equipment. This is where the rubber meets the road. Now part 5 of ASHRAE 62.1 gets deep into how systems should be built and installed to support good indoor air quality. So I'll go over each of these items and then I'll highlight the most important that I think. So we have our building and envelope requirements. We have our smoking areas. We have our outdoor air intake requirements. So that's our clearances, distances from exhaust outlets, bird screens, rain intrusion, prevention, etc. We have our exhaust duct locations. We have our particulate matter removal, our coils and drain pans, our ozone generating devices, so that's our air cleaning and our UV detection. We have our ventilated air distribution systems and controls, our Legionella risk, and there's a lot more on top of that. Let's break down a few of the highlights. Outdoor air intakes. These need to be far enough from exhaust outlets to avoid recirculating contaminated air, and they need to be protected with things like bird screens, hoods, and drainage paths. Also, coils and drain pans. Coil hygiene is huge. Dirty coils can not only reduce the efficiency, but they can harbor mold and bacteria. Drain pans must be sloped and accessible for cleaning. Let's talk about filters. If you're in an area with high particulate pollution, you'll need filters rated at least at a MERV 8 for PM10 and MERV 11 for PM 2.5, and you'll need to prove it. We also want to point out exhaust duct placement. You don't want restrooms, kitchens, or lab exhausts dumping air near intake louvers, so layout does matter. Take that into consideration. Now, one of the most talked about sections in ASHRAE 62.1 is how to calculate how much air you need. And the standard gives us 3 different methods. Now, our most common method is our VRP, or our ventilation rate procedure. So in this case, you take a space type, so like a classroom or a daycare, or maybe we have a cell in a correctional facility, and then we get the number of expected occupants, which is the number of people in the room, and also the floor area or the square footage. And boom, with those 3 numbers, the standard will tell us the minimum CFM per person and also per square foot. So for example, we might have an art classroom that might require 10 CFM per person or 0.18 CFM per square foot. Multiply that out, and you will get the number of required outdoor air intake. Now, the next method is our indoor air quality procedure, or our IAQP. Now, this one is performance-based. So instead of using preset numbers, you prove that your design meets contaminant limits using measurable or models. So it's more flexible, but also riskier. If you guess wrong or you don't monitor the situation, you might fall out of compliance, which of course we don't want. And then our third method is our natural ventilation procedure. This is used when buildings are naturally ventilating, using devices or parts of our building like our open windows or our louvered air intakes. And this is only when we can prove that our airflow meets the indoor air quality needs. So to kind of sum up the 3 different methods, our VRP, or our ventilation rate procedure, is the default on most projects. Our indoor air quality procedure, or our IAQP, is used when energy is a big concern, and natural ventilation procedure is great for certain climates and building types, like atriums or open air campuses. Now, each procedure does need to make sure that they treat the outside air in accordance with the standard. So before you can decide on how much air to bring in, you need to check one thing. How clean is the air outside of your building? So ASHRAE 62.1 says you must assess outdoor air quality. Specifically, our PM10 and PM2.5, our ozone, our CO2, and any other regional pollutants. So if pollutant levels are above national thresholds, you'll need to add filtration or treatment before that air comes in to our building. So for example, say you're designing an office building downtown near a freeway. You check the EPA database or you pull sensor data and realize that the PM 2.5 is regularly above safe levels. Now that's a signal, right? We need to bump our filters up to a MERV 11. Maybe we add a UV or a carbon filtration if our VOCs are a concern. Now, in addition to our outside air intake rate that we just talked about, the standard also provides procedures for exhaust air rates. So here are the minimum exhaust rates in Table 6.2. Now this is broken into categories for our occupancy by types of spaces. So we have arenas, we have art classrooms, barbershops, go down the line, and they all have different types of exhaust rates. So your exhaust rate for an arena is going to be different than a cell with a toilet. Now, no matter which procedure we use, there are advanced calculations and consideration used by the engineers who are designing this. This is to determine the proper amount and type of ventilation that we need, whether it be intake, exhaust, or air treatment. And again, this is needed for each particular space within a building. Now, here are some more advanced calculations that I won't go into in too much detail, but we do have our ventilation rates where we look at our zone floor area and our population. We have all our sums or mixed sums here. And then we have some other rules where we have 6.2.3 talks about our 100% outdoor air systems. So for these ventilation systems, we have a zone or outdoor where it's equal to the sum of all of our zones. We also have a multi-zone recirculating system. We have our uncorrected outdoor air intake. And we also have an occupant diversity. Now, once everything is designed, built, and installed, the job still isn't done. Now it's time to commission. So we've got to verify a few things. First, we got to make sure that air is actually flowing as designed. We also need to make sure that our dampers are open and closed. We have to make sure that our sensors are calibrated. We also need to make sure that our controls respond to the demand. These are not optional. A well-designed system that's not commissioned properly is like a Ferrari with a flat tire. Just doesn't work the same. Now we need to follow that up with some maintenance. So the ongoing maintenance that usually happens with this, and some of these questions are, how often are filters changed? Monthly, bi-weekly, yearly? We need to understand that We need to keep a record of that. Now, another question we come up with, or we have, is, are the damper motors tested? Right? We need to make sure that everything's operating properly. And then another question we have, specifically for our BAS, are the sensor alarms configured properly? Bottom line for that is, we need to create a plan, schedule inspections, and document everything. So we say here that it's advisable to have a BAS track our performance and utilize that alarming to ensure that we have proper ventilation operation. We need to have proof in the pudding. So let's wrap it all up. So ASHRAE 62.1 has a purpose, a very big, important purpose that probably doesn't get talked about enough. It's to ensure acceptable indoor air quality, or our IAQ. It's also to minimize health risks, apply to new and existing non-residential buildings. We're trying to make sure that indoor air quality is good and healthy to breathe in for our occupants. The scope of that is encompassing of our ventilation design. It's also making sure that we're cleaning our air, and then also our operation and maintenance, or our O&M. Now again, we talked about this last week as well. This excludes residential dwelling units. That's 62.2. So now for our systems, the outdoor air must be assessed and filtered if needed. The systems need proper intake and exhaust locations, filtration, drainage, control measures, and a bunch more. Now we have three main types of ventilation methods. Our VRP, based on the people and the space. We have our IAQP, which is performance-based. We have our natural ventilation. So this is if our conditions are met. Now, commissioning and maintenance is very important. We got to test and balance our system, and then we need to make sure that we document the system performance. From all of that, or after all of that, we need to make sure that we're maintaining with our inspections, our filter schedules, and also tracking our BAS performance. So in summary, I'd like to point out that it protects the people, it makes sure that the air is healthy, and that it applies to almost every commercial project we work on. So from proper air intake design to MERV filters, from VRP calculations to indoor air quality testing, it's all in the 62.1 standard. Thank you for listening to the Smart Buildings Academy podcast. We hope you learned a lot from this episode. If you found this episode valuable, please leave us a 5-star review on Apple Podcasts or Spotify. If you're watching this on YouTube, please like, comment, and subscribe. And if you're watching this on LinkedIn, please share with your network. As always, this will be available on our website at podcast.smartbuildingsacademy.com/492. Again, that's podcast.smartbuildingsacademy.com/492.